Welcome to the P1 Block 1 orientation webinar to accompany the new Glasgow City Council Numeracy and Mathematics Progression Framework. If you haven't already been able to, there is a Microsoft team available for you to join and collaborate with colleagues as we implement this new framework. The name of the team is GCC Numeracy and Mathematics Progression, and the team code to join that is MPQ79UM. You'll find in this team all of the webinar recordings, all of the progression documents that we're piloting, and there are folders there for practitioners to share resources which can support in the teaching of the blocks. As we start this implementation, I want to just draw attention to what's staying the same and what's new. So, as we've had in the past, there is an annual overview which explains the content that's expected to be taught in each primary stage. The research hasn't changed, so we're still expecting practitioners to deliver their mathematics teaching through a concrete, pictorial and abstract approach to introduce the new concepts that come along each stage. Problem solving will remain at the heart of our teaching, giving real-life context and purpose to the mathematics learning that pupils are undertaking. And as ever, we'll have high expectations of fluency with mental strategies. So all of those mental math strategies we've been practicing for years are still absolutely required. All of the resources you have been used to using in your classroom, whether that be textbooks or particular online sources, will all still be useful and relevant to the new teaching framework. Really what's new is what you might refer to as the technical framework, so the structure and delivery of the content. So on the right hand side there, what's new is that now we have our year content split into 6 teaching blocks. Each block is to last about 6 weeks, and there's rough guidance around the timeframes of those blocks. Core number concepts are revisited in each teaching block every 6 weeks. So instead of spending 2 or 3 weeks looking at division, for example, we'll be looking at division concepts every 6 weeks and building incrementally through bite-sized steps so that pupils have time to internalize and move through those skills at a slower pace, but revisiting them multiple times in the year. The intention is to create end-of-block assessments to be available for teachers to use should they wish. These are currently in development, and there'll be communication about those at the beginning of next session. What you also have alongside the annual overview are populated medium-term planners, which explain each block and offer suggested learning intentions split over 6 weeks that would help you cover that block of teaching. What we will be moving to, it's a slight departure, is specifying which strategies are most appropriate at each age and stage. So when to introduce column addition or multiplication, when to try to move away from grid method, for example. And that's driven by helping to prepare our pupils for the SQA exams which come in 3rd year and beyond at secondary. Yes, at primary we want to promote conceptual understanding before speed, but ultimately they will be in timed exams. So we need a progression which helps the on-track learner to move towards the most efficient methods. And in the same way, we've included in this new framework a number fact knowledge progression, by which we mean indications of when children should be secure on their number bonds, on recall of doubles, on times tables knowledge. And that's really just to help to pace the learning of those facts over a number of years such that we have the best chance of pupils becoming fluent and efficient with those facts. So the annual overview looks something like this, and you will find the PDFs available in the Microsoft team that you can print. It's best to print these on A3 paper, that's how they were designed, because obviously there's a lot of content on one page there. You'll see the blocked planning progression. Up at the top, you've got an indication of which year group this is for. Along the top, you can see the timeframes suggested for each block of delivery. And down the side, you've got what we might call organisers or areas of the maths curriculum. So each block, if you look there, that's block 2 for primary 1, that's highlighted in blue. Each block contains some skills in each organiser, and we need to cover those skills within the 6-week time frame. Accompanying each block, you also have a block overview like this. 3 columns, and the core teaching skills are sitting in the middle of that. So here's your core block in the middle. Then to the right, you've got indications of how to provide further challenge for pupils who are ahead of track. And on the left, you've got indications of what you can provide to support learners who are not yet on track with those skills. It's worth saying at this point that the support block is not very far behind the on-track middle block here. So what we're looking at is those that are just off track on this overview. You may well have pupils in your class who are working at a level far further behind or far earlier in the progression than the block that is on track for age and stage, in which case you would want to be looking at a different year group, or in the case of P1, looking at the developmental milestones documentation to support you with what those learners might be looking at. On the right-hand side of the planning pages, you'll find a set of suggested learning intentions to cover the block of teaching over 6 weeks. These have been created just to show you how you might cover that content over the course of 6 weeks, to give you an indication of how long to spend on addition or multiplication or whatever. Each week's set of learning intentions includes core number topics and wider maths topics to be taught in parallel. This is to mirror current practice and to also facilitate ease of planning for job share partnerships in the way that is quite common at the moment. Learning intentions are also there to help early career teachers to get used to what learning intentions should sound like and look like in order for them to be child friendly. And so, in line with best practice, the specifics of the skills that are being learnt would not appear in your learning intention, but in your success criteria. And that way they may be differentiated across several groups, but the whole class will be able to access the same learning intention because they're looking at the same concept area of maths, but at different parts of the progression. So everybody is working on multiplication or division, but they might be doing quite different skills within their groups. So the rest of the webinar now moves through the teaching points of Block 1 for P1, just to remind you of the types of activities and pedagogies you might want to use in order to deliver these. So we're starting with number system and number fact recall, which is the first organizer at the top of P1 Block 1. Although we're talking about these from top to bottom of the block, if you like, actually the skills that you'll see particularly in this organizer about counting and recognizing and using numerals will cross over into other areas. So we will be revisiting these, for example, as we look at addition skills, because in order to add, we will need to count and we will need to use numerals. So whilst I'm talking about them as distinct teaching points, and they may be the focus of certain lessons, we are clear that there will be opportunity for these skills to be used in other areas as well. So in this block, we're looking at numbers to 10 only, no further. Counting forwards and backwards, learning to recognize, identify, and write the numerals, and we're practicing a one-to-one correspondence by counting objects. As the P1 blocks progress, we revisit and extend these skills to numbers to 20 in block 3 and to 30 by the end of P1. All the time remembering that what we're talking about here is the core journey of an on-track learner. Some pupils will need support beyond P1 on those concepts, and some may arrive in P1 already confident with numbers way beyond 30. And that's where our support and challenge columns can help us to extend their learning or support and scaffold. In terms of the first teaching point then, suitable activities and resources for teaching counting forwards and backwards include things like number songs and rhymes, so 1, 2, 3, 4, 5, once I got a fish alive, 10 green bottles, 5 little ducks, any of these, one man went to mow, etc. That can be during your core teaching time, when you're lining up, tidying, just as part of your general classroom excitement and fun. We use lots of countdowns in terms of our classroom management. Those are really helpful in terms of helping the children to think about that counting backwards skill. Think about potentially not always starting from 5, start from 7, start from 9, why not? So that can be really helpful. Be mindful if you are doing countdowns or thinking about countdowns for rocket launches, then yes, by all means, have fun doing blast off, but they do need to be aware that after 1, when we're counting backwards, we're going back to 0. So make a point of pointing out 0 as well. Giving children exposure to simple board games like Snakes and Ladders, or any board game that's got a basic number track to follow as they roll the dice and move along is helpful. It internalises the idea of the number line very early. Number tracks as well, because they've got a physical space instead of a point on a line, are a good precursor to the type of number line you can see at the bottom of the slide there. So have a think about if you can include board game type activities in your environment. The number line at the bottom of the slide there, where we've got numbers on the top and Jack and Jill rhyme written underneath, is to demonstrate what you will all be very familiar with, that just because a child can say the numbers 1 to 10 in the correct order doesn't mean that they have a good idea of what those words mean. So just in the same way as they might know to rhyme off the alphabet song long before they have any awareness of letters, letter shapes, phonemes, or being able to read, the sequence, the actual rhyme of saying numbers 1 to 10 and back again is only the beginning. If I was to cover up the numbers on that number line that are associated with each word and start asking you to do calculations like what is fetch, add pail, you would have to pause and remember what each of those stood for. So we need to layer on lots of representations of the value that the numeral represents in order to help children to get a sense of the threeness of 3, if you want to speak of it like that, or the two-ness of 2. So things like dot patterns, finger patterns, use of 10 frames, if you have rec and rec frames in your establishment, and things like tally marks are all really helpful in terms of internalizing the patterns of 5s and 10s and the subitizing skills that come along with that, which we'll look more at in block 2. They need a deep conceptual understanding of what each number word means, and so we need to work on that just the same way as we would be providing lots of different inputs for letters through our phonics. Which brings me on nicely to this slide. So this teaching point is about recognizing, identifying, and writing numbers to 10. The phonics analogy is helpful here because to be confident with numerals, the shape of numbers, if you like, pupils need to link that squiggle on the page with the word they've been saying in the sequence. They need to practice both recognizing numerals, so if they have numerals in front of them, being able to correctly point to a number on request, so can you point to the number 2? And as a separate skill, but very much related, being able to retrieve the number word, being able to say the number word when they see that squiggle, when they see that shape on the page or on a card. So if a teacher shows a flashcard with a number 3 written on it and says, can you tell me the name of this number? They need practice to be able to recall what each of those squiggles means. And we're very good at doing that with letter shapes, what the letter looks like, what the letter sounds like, and then using it later in sentences and in words. And then the linking those squiggles and the word that we're saying with the representations of that number. So being able to match, for example, 3 on the dice with a numeral 3, or count out 3 counters that match numeral 3. And all of that learning will underpin every other mathematical concept that we try to teach. So it's worth spending lots of time on. On the point of being able to write the numerals, just as with letters, it's important to note that this is a writing skill. And so actually it doesn't appear in the mathematics benchmarks because it's dependent on physical development and fine motor skills. However, for those pupils who are developing pencil control and who are starting to produce letters as well, we should be modelling and practicing number formation. What we don't want to do, however, is to be judging a child as off track rather, if number formation is incorrect. So in the third photo there, a pupil has correctly written the sequence of numerals to 10, but some of them are reversed. What we want to do is celebrate the achievement of the sequencing here and the awareness of those numerals, not penalise for the reversals. That will come later. Finally, in this section, practicing one-to-one correspondence with concrete objects in a row. It's much easier to count objects in regular arrangements than when they're in a random arrangement. So what we should do is model and expect pupils to line things up when they're counting them. It will make things easier for them, and that early expectation of orderliness and systematic working will set them in good stead later on when they come to using things like Dean's materials. We should model the counting process by indicating each object as we count it, touching it as we go. We draw attention to the fact that we've stopped counting at the end of the line, because that's the last object. Many children will go through a developmental stage of continuing to count, counting the line again, etc., especially if it doesn't go all the way to 10, which they've been used to practicing. So we stop at 8 if we've got 8 items, and we draw attention to the fact that this tells us there are 8 items in the line. We mustn't take for granted that children understand that by finishing our counting, this tells us how many there are. Building on these skills later, pupils will be able to count a much higher number of items, up to 30 items by the end of P1, again, for our on-track learners. So moving down the block to our next organiser, we've got 2 teaching points linked to addition and subtraction. The first 2 blocks of P1 look at addition only. Subtraction will be introduced as a concept in block 3, and we will come back to addition again in blocks 4 to 6, looking at number families and introducing an early understanding of the inverse. In this first block then, we're going to explicitly introduce the addition and equals symbols and begin to read and model through addition calculations within 10, so totals no more than 10, using concrete materials to demonstrate the concept. So this first teaching point then is simply the introduction of those two symbols to express the concept of two parts making a whole. In block 2, we'll look at cherry diagrams and bar models and the number families that can be created there to further embed that idea of part, whole. But here we're moving from familiar language, so as in the top picture example there, 3 counters and 2 counters makes 5 altogether, and converting that, or laying on top of that, a mathematical version of that number sentence using the add sign and equals. So we want then, if we move on, having explicitly introduced these mathematical punctuation marks, if you like, we should be able to have most learners able to read and solve simple calculations of this type. So because they've been working on recognizing numerals, they can tell us that's a number 3. We've introduced this symbol and it means add, and add means and. They recognize a number 2 now, and we've got this new sign that we've introduced called equals. So this is what a basic number sentence looks like, and we would want our pupils to be able to say to us 3 add 2 equals. And then we're going to support them to model that through with concrete materials. So counting out 3 cubes using our one-to-one correspondence skills, so all the time revisiting those skills from number system skills and the organizer we've just talked about. So counting out 3 cubes, and I'm going to count out 2 cubes, and the equals sign is asking me how many have I got all together. So we want them to have a good understanding that then we're going to put these 2 groups together and see how many we've got. Pupils might need to then count the whole group again, starting from 1 at this stage, and that's fine. Counting on from the 3 will come later, and you can model that and say, so we have 3, 4, 5. So moving down the block again, next organizer is multiplication and division, which traditionally you might feel doesn't fit in primary 1. However, there are foundational concepts that we do teach in primary 1 that provide the framework, provide the foundation for later work in these areas. We're going to introduce the concepts of odd and even and help pupils to begin their awareness of equal groups, which they will need as we introduce repeated addition later. Both of these are core concepts, and we'll revisit them in later blocks as we extend pupils' confidence with numbers to 20 and then to 30. So our skills here are just identify odd and even numbers to 10, well, to at least 10 in fact, and B, find matching groups to a total of maximum 10. So 2 groups of 5, 3 groups of 3, for example. So in terms of odd and even numbers, these are core to the concept of shareability and number patterns. Representations of numbers that emphasize the idea of odd and even are really useful. So 2 resources that you might consider that are on the screen there are Numicon, or if you look at MathSpot, they talk about these shapes as number frames. So the idea of Numicon is that because it's shaped such that an even number has a flat top and an odd number has an additional 1 in its layout, so it's got a sticky out bit, then it's a very recognizable representation of odd and even. And those are based on the 10 frames layouts that you can see underneath. That's called pairwise 10 frame layouts. You also see a sequence with 10 frames where the top row is filled up first, so 5 on the 10th frame would be 1 row complete. That's called 5-wise layouts, and they're both really useful for different things. So you can imagine this pairwise layout is very helpful for doubling, and in the same way for odd and even, it gives us that visual of whether we've got pairs or not. Odd and even is the first time where children are encountering different types of number sequences. So they're not just counting 1, 2, 3, 4, 5 here, but looking at the pattern of the evens, we get the sequence 2, 4, 6, 8, 10. Looking at the pattern of the odds, we get 1, 3, 5, 7, 9. And so this is the very first introduction of the idea that we can count in different ways. And when we look at the number line, we can show them the model that the odd and even numbers alternate, and that if we want to count in the even numbers or the odd numbers, we're going to skip one of the numbers each time. And that's obviously setting them up well for counting in 2s or counting in 5s or counting in 10s. Real life examples of things that occur in pairs are useful too, and this is obviously laying the groundwork for doubling, which we'll come to in block 2. So things like shoes, socks, bicycle wheels, etc. And this also naturally underpins discussions about fairness. So if we've got an odd number of children and we want to make 2 teams, it won't be fair. And there'll be lots of opportunities in day-to-day classroom life where that idea of we can't make equal groups will come up. We can draw attention to that as a concept. Which brings us to the second teaching point, the idea of finding matching groups. So here we're laying the foundations for repeated addition, which will be introduced at a very simple level in block 3 and then more in P2. Pupils should be given practice at spotting equal groups. So finding all the 5s on a number of dice, noticing when a group doesn't match, like in the second example. So there we've got 2 groups of 3 dolphins, and then there's one group that doesn't match. So being able to visually identify that. We need to build the concepts and the vocabulary use, things like same and different, more and less, and give an understanding that they can talk about groups matching in terms of number of items. So we may, for example, make some groups of cubes or counters that are in different colours, and the children should be able to identify where a group matches in number, even if the colours are different. Very much linked to multiplication and division, we have one teaching point to introduce the idea of fractions, and that is to recognise half of an object or a shape. So yes, we can look at 2D shapes drawn on paper or cut out of paper. However, really what we're interested in this block is just the concept of halves having to be exactly equal. So as adults, we're not very good at being precise about that. We quite often might say, oh, don't worry, I'll have the smaller half, or you can have the bigger half. Actually, if we're talking halves, they must be exactly equal. So this links really closely to concepts we've already discussed in this block about fairness and the vocabulary of comparison. So what's the same, what's different, what's bigger, what's smaller, okay? And fractions being exactly equal. If we build on this in later blocks, fractions appears in every block of learning. We're going to incrementally breed familiarity with fractions, build a fraction sense, just like we build number sense. And hopefully by the time they get to primary 4 and primary 5, they won't have the same fear of fractions that perhaps some pupils currently do, or perhaps we did when we were at school. So moving on from the core number topic, each block of teaching has 2 areas of beyond number to touch on, and those are revisited through the year. So in this block, in block 1, we have shape and space, which appears in this block and again in block 4. And we also have information handling, which appears in 4 out of the 6 blocks, because it's very much linked to our core number skills and in assessments, and as well as they move up to SQA, information handling questions very much appear frequently. So just to underline, these core number topics we've discussed so far are in every teaching block and built on in a spiral way to ensure that retrieval practice is built into our planning. For shape and space then, we've got these 4 teaching points. Name common regular 2D shapes, sort 2D shapes according to criteria, create symmetrical models, and follow and give directions using language of position. So things like in front, behind, etc. So in terms of common 2D shapes, what we're really interested in is these 4 core shapes and their properties. Some children will be aware of more complicated shapes or polygons with more sides than this, but what we want to do is hone in on these very familiar shapes and teach the vocabulary around corners, sides, curved, straight, and have them compare and understand that in order to know about the naming of shapes, they need to look at the properties. So sorting circles and online games can be used. I'm sure you know others as well as that top marks one I've dropped in there. And the middle photo there is to show an example of a simple shape hunt in your environment. So having looked around and tried to find items that match the core shapes we're investigating. And equally, the sorting circles on the left, although that's with pictures of shapes, you could sort the items that you've found around the classroom. In terms of symmetrical models, yes, we are looking for lovely experiences and for them to understand the basic concept of a single line of symmetry. So lots of provocations can provide opportunities for pupils to explore and create models using symmetry. And staff can make comments and observe in the moment with pupils who are engaging in child-led experiences where they're demonstrating an awareness or an application of symmetry. And that might just be incidental, but you can imagine on the right-hand side there, the boys that have been building the Taj Mahal, how an adult interaction at this point could absolutely draw attention to the learning that they've done and the application of the idea of symmetry, and potentially, depending on the confidence of the pupils, maybe even improve the model so that it is more symmetrical. And you could have the same discussion about the little Lego bed in the middle there, lovely and symmetrical. We need to make sure that those flags on the back definitely point in opposite directions if we want it to be properly symmetrical, and we could have a discussion depending on the child of whether the flags ought to be the same colour or not. But you use your professional judgment in terms of that precision and how much we're celebrating the general application of the concept. The little bumblebee made out of Lego on the left shows a level of precision that is greater, more precise than perhaps the butterfly picture, because Lego is made with a grid. So there it's much easier for children to precisely place things symmetrically using something like Lego or a grid, because they've got a guide, and we would expect that as they move through the primary stages for that precision to improve, and we would provide tools to support that. Our last teaching point for shape and space speaks to that idea of constant embedding through the wide range of experiences that you would be providing for your pupils anyway. The language of position does need to be explicitly taught. We can't assume familiarity for our pupils, and especially for those pupils who have English as an additional language. They may be familiar with the concept of in or on top or behind, but they may be using those concepts at home in a different language, and so we need to layer on to that the English vocabulary that they need. So we do need to explicitly teach those vocabulary items, as well as having directional language experienced through the everyday routines like tidying up the classroom or the way that we position things in the classroom. So explicitly explaining that water bottles go on top of the bookcase, and maybe even having signage with those terms as children become readers. And then child-led experiences both in the classroom and outdoors using physical materials and provocations give loads of opportunity. So you've got the small world type setup at the top right. We've got some loose parts happening at the bottom left, and then there's a kind of mud kitchen type potion making going on where I'm sure they're putting lots of things in and stirring things around and adding them, and there's lots of vocabulary going on there that we can celebrate. Finally, we have one teaching point in the organiser of information, data and uncertainty. Engage with a range of environmental displays. So we've got examples there of the calendar or weather chart, the lunch menus, visual register, health and wellbeing check-ins. So as you welcome a new cohort of P1s into your classroom next session and you settle them down, there will be a range of environmental displays and systems that you set up with which they are becoming familiar. Explicitly teaching the relevance of these displays and ensuring that all pupils are aware of what they're doing, what it means to the pupils and why they should engage with them is laying the foundations for more mathematical displays which will be introduced in later blocks. Teacher-led group work could be spending time reviewing the must-do task board, for example, which would involve retrieval of counting skills as well as explicitly engaging with this display of data. So how many people have completed their must-do task so far? How many are yet to complete their must-do task? How many girls have done it? How many boys have done it? Okay? So using what you're doing anyway to deliver these early concepts and making sure that it's linking with your whole classroom setup, not just being separate teaching. So that's us got to the end of the walkthrough of P1 Block 1. If you'd like to provide us with some feedback, this feedback form will remain open even if you're watching this after the event as the recorded webinar. All the feedback's really helpful. It will help us improve further webinars. As I mentioned early on in this session, the intention is to produce end of block assessment materials that will align with the blocks that can be used by practitioners if that suits your QA calendar. Those will be communicated early in term 1, 2026-27, which hopefully gives you enough time before the end of block 1 to decide whether you're going to use those or not. I'll be running block 2 webinars in the same way in the new session and beyond. So the block 2 webinars will take place in early September. They'll be up on CPD Manager from the beginning of the session. And in the same way, all of them will be recorded. You'll be able to access them through the Microsoft team. Just a reminder of that team code on this slide too. And that's my email address if you have any questions or need any further support at this time. At the very end of the presentation, and if you want to download the PDF of these slides, you'll find some useful links that refer to resources that I've mentioned during the presentation. And there's also a placemat there with QR codes to the various manipulatives you can find on MathSpot. So if you're using the iPads in your classroom and you'd like children to play with the counters or the number frames, for example, then you can have them access that through the QR code in a very simple fashion. Thanks ever so much for listening. Hope that was useful and hope to see you again in